I have three P series. Are they converge or diverge? Let's find out. The first one is 4 divided by base raised to 5 over 2. So what we are looking at is the power. So for a P series, this power is 5 over 2. When the power is greater than 1, the series converges. And then the next one, the power is equals to pi. Oh, by the way, this P, I don't think that really represents power. The P series, the P, the letter P is really stands for a parameter, I guess. I don't think the P represents the word power. So the P is equals to pi. P is equals to pi. Pi is greater than 1, so that converges. And then the last one, this one is fun. This one, the P is equals to 1. When P equals to 1, then this is a harmonic series. Always diverge. Okay, I would like to take a look at the first one, converge. Why? Okay, then let's open this up. What is that equal to? When n is equals to 1, I have 4 divided by 1 to the 5 over 2. The 5 over 2, I would like to use a square root 1 to the 5th power. And then plus 4 over the square root of 2 to the 5th. Plus 4 over the square root of 3 to the 5th. Okay, everything looks good until we reach to this. 4 over the square root of 1,000 or 100 to the 5th, and then you keep on adding. What happened when the base is very large? So when the base is very large, what happened in here? So that this is a sum of many small values. Because you have 4 divided by a huge denominator. So therefore, the sum of this value, they are approximately equals to 0 when n is large. That means the sum is determined by the first couple values. So then when the n is small, so when n is small, the sum is determined by the first couple terms. By the first couple terms. Alright, the sum is determined by the first couple of terms when n is small. So when n is large, you have 4 divided by a large denominator. Those values are nearly 0. So you are adding up a bunch of 0 that doesn't affect the sum. So when n is small, when the base is small, that is where you are able to determine the sum. Okay, then we just went over 3 P series. Let's do one more. The next one, how about this? Okay, I'm going to move this up, and then we have a summation. N goes from 1 to infinity. How about 2 divided by n to the 0.5? What is the P? P is between 0 and 1. Again, P cannot be equal to 0 because n to the 0 power is 1, then you have a 2. Diverges. That is based on the P series. How do you know that it diverges? Okay, let's open this up. 2 divided by 1 to the 0.5 plus 2 divided by 2 to the 0.5 plus 2 divided by 3 to the 0.5 plus 2 divided by 4 to the 0.5, and then you keep on adding. What happens when n is large? When n is large, then you will have these values. 2 divided by, I will just draw a very large base. 0.5, and then you keep on adding until you will have this. A very, very large base raised to 0.5, and then you are still adding. So what happened to this? You can use a calculator to find out when 2 divided by a huge power raised to 0.5 power. So this quantity, they are nearly 0 when n is large. When n is large. All right, and then what happened for the first couple terms? So this term, what happened? Are we able to determine the sum? Okay, then you can say, all right, 2 divided by 2 over 0 0.5, 3 over 0 0.5. These values, they are not arbitrarily large, and then you can say the sum is determined by this term. When n is small. Okay, that sounds like converge, but based on the P series, when P is between 0 and 1, the series diverges. But why? We already say the sum can be determined by the first couple terms. Okay, then let's take a look at what those terms equals to. The first 4 terms, you can easily get that using a calculator. What about this? When n is equals to 60, you have 2 divided by 60 raised to 0 0.5. When n is equals to 100, you have 2 divided by 100 to the 0 0.5. To the 0 0.5. And then when n is equals to 10,000, you have 2 divided by 60, not 60 anymore, and this will be a 10,000 divided by to the 10,000 are not divided by raised to 0 0.5. Okay, this one I believe I make a little mistakes on my notes already, so I will just use my calculator to do this right now. So we have a 2 divided by 60 raised to 0 0.5 power. Let's see what that equals to. That is around 0 0.258. 258. And then what about 100 to the 0 0.5? So I will change the base to 100. And then this is exactly 0 0.2. And then change that to a 10,000. 10,000. And then this one is a 0 0.02. What happened in here? So when the sum gets pretty big, like this, 10,000. So that means the sum is equals to a real number. Yes, we are adding up a bunch of these small values, but we are unable to determine the sum. This value is not going to give you an infinity, but the sum, we are unable to determine what it is. Just like the graph of a function, the function is increasing, but increasing is not going to go up like that. So the function is increasing pretty steady, slow and steady. Slow and steady. But we are not able to determine when is this function going to stop. If the function increases and then eventually stops right there, so that's just like something that approaches to a curve that approaches to a horizontal asymptote as x goes to infinity. Yes, we can determine the sum. But this one, if you look at the function, this function will just keep increasing, slow and steady, but there is no upper bound. And then we will say the series diverges. All right. Okay, let's do one more. The last problem, how about we try this? The last problem, they are not going to give you a series. This is the given. They will give you 1 plus 1 over the cube root of 4. And then they use a cube root, but they will change the radicand from 4 to a 9, and then from 9 to a 16, and then from 16 to a 25. And then still keep on adding. Okay, and then the 4. The 4, I will treat that as 2 square. The 9, I will treat that as a 3 square. The 16, 4 square. The 25, that is a 5 square. So that is always a square. And then I can write that as 1 plus, this is your work, okay? They will only give you the first line. And then everything underneath this line is for you to figure it out. Okay, this is a 2. How about 2 over 3? That is correct, right? And then plus 1 over 3, 2 over 3, second power, over 3, the over 3 refers to the cube root. And then 1 over 4, 2 over 3, and then plus 1 over 5 to the 2 over 3, and then we are still adding. This one we can say n equals to 1, n equals to 2, n equals to 3, n equals to 4, n equals to 5. Because 1 to the 2 over 3, that is still equals to 1. And then we can treat this as 1 over 1 to the 2 over 3, which is equals to 1. And then what is the series? The series that is equals to summation. N goes from 1 to infinity. I have 1 divided by n to the 2 over 3. And then this is a p-series. And then we have the p between 0 and 1. And then the series diverges. The series diverges. We are unable to determine what the sum is. Okay, so that is the end of this video, and then in the next video we will mix the p-series, the harmonic series, and then with the integral test. So I will go over examples regarding the integral test. All right, I will see you there.